Alright, so for section 5.7, we're going to talk about some more inverse trig. And we won't get so much into the differentiation. We're going to catch that a little bit later. But I want to talk to you a little bit about some inverse trig things here. So we have we use this word arc to represent inverse trig, or the inverse of a trig function. So, same way that multiplication or has inverse of division, addition has an inverse of subtraction. How we undo trig is just by taking the inverse of it. We can denote that two ways. You can say arc, arc sine, arc tangent, arc cotangent, arc cosine, or you can just raise it to the -1 power just to denote, okay, this is the inverse of the trig function. Okay? And so by definition, and this applies for all trig functions, but by definition, the arc sine or inverse sine of a value x is equal to y, then the sine of y is equal to x. And this is for all trig functions. Okay. All right. And so we want to be able to solve these algebraically without a calculator. And in a pre-calc course, you would learn how to solve the regular trig functions, but here we're going to do the inverse trig functions. So let's say that we want to figure out we'll say arc cosine of the square root of 3/2. All right, and we want to figure out what the value of this is. Okay, so I'm going to just set it equal to our unknown. We can just say theta as our unknown. Okay. So to undo arc cosine, I would just take the cosine of both sides. Okay. So I have that the square root of 3/2 is equal to the cosine of theta. Okay. Now, ideally, in a Calc 2 course, we want to be able to solve this without using the unit circle, or without being able to reference the unit circle. Now, if you do need to reference that, of course, obviously do that. All right. So what we're going to do is I want to show you this using right triangles. Okay. So we have a right triangle. Let me make it a little bit bigger just for the sake of making sure you can see it. Okay. So we have this right triangle. All right. And our two basic right triangles that we deal with are 30, 60, 90 triangles. Okay. Or 45, 45, 90 triangles. Okay. And if you look on your unit circle, and you look around the circumference of the circle and the points, right? You have options of 1/2 square root of 3/2, or you have options of the square root of 2/2 and the square root of 2/2. Okay. So of course here we have the square root of 3/2, right? So that's so we obviously know we're going to deal with a 30, 60, 90 triangle. All right. So now I need to establish where my which angle that I need to look at. Well, cosine, if you remember, always goes with the adjacent side, right? It's the adjacent over hypotenuse, but the hypotenuse is just 1, okay? Because the unit circle would have a radius 1. All right, so the cosine always corresponds to the adjacent side. Well, the adjacent side that corresponds to 3 over 2 is 30. So what we want to look at is to say, well, the cosine of 30 would give us our square root of 3 over 2. All right. So to answer that in radians, okay, so to answer that in radians, the cosine, excuse me, well, if I can get this to erase. All right, well, anyway, so if you do look at your unit circle or don't know it exactly well, then we would know that the theta that corresponds with 30 degrees is pi over 6. Okay? And so then this would be our answer. It's pi over 6. All right? And you can do this for any triangle, and you can, or any value of cosine, tangent, sine, etc., just by using these two triangles here to establish that without ever using a calculator or without ever needing to reference your unit circle. All right. Let's go ahead and look at another example problem. All right. So let's say that we wanted to figure out what the tangent of arc secant of x over 6 is. Okay. So there's a lot going on here. Arc secant, right, would just be the inverse. So we'll say the arc secant of theta is just the inverse of secant, right? All right. And you may not remember this from a previous section, but it's okay if you do. It's in the textbook. But the secant of theta is equal to 1 over the cosine of theta. Okay. So I just want to make sure that you remember that. All right, so let's solely focus on the arc secant of theta, or the arc secant of x over 6 here. So we have the arc secant of x over 6, and we'll just say it's equal to theta. Okay, so we're just trying to solve for an unknown. That's all we're trying to do here. All right. Well, to undo arc secant, I just take the secant of both sides and say, well, the secant of our unknown angle theta is x over 6. Okay. So then, because I know that secant is 1 over cosine, all right, so I know secant is 1 over cosine, then I'm just going to really say, well, that x over 6 is equal to 1 over the cosine of theta. Okay. Doing some algebra steps, you would find that the cosine of theta is just equal to 6 over x, right? Just flip it over. All right. All right, so now we have that the cosine of theta is 6 over x. All right. Well, something else that I also know, I'm dealing with tangent. All right, well, tangent is equal to sine over cosine. So I need to somehow incorporate a sine value in there somehow. Okay. Well, the easiest way to do that is I know that the Pythagorean identity says that the sine squared of theta plus the cosine squared of theta should give me 1. All right. So that is to say, if I do the algebra, so I move cosine over, take the square root, all right, then I have that the sine of theta is equal to 1 minus cosine squared, so 6 over x squared is 36 over x squared. All right. To just give this a common denominator, just to make our lives a little bit easier, I'm actually going to say that is, since since x squared over x squared would give me 1, I'm going to say x squared minus 36 over x squared. Okay. So now I have a value for sine. I have a value for cosine. Well, I know that the tangent of any angle theta is sine theta over cosine theta. So tangent of theta will be this sine value of x squared minus 36 over x squared, the square root of all that, over 6 over x. Well, of course, that's an improper fraction, and so we want to make sure we simplify it. And after we do the simplification, we'll have our answer. So I'm going to come over to the next page for some room. All right, so I have x squared minus 36 over x squared, the square root of that, times x over 6. All right. And so remember, I'm just saying that the tangent of our arc secant x over 6 is what this is all going to equal, okay? Well, the square root applies to both the numerator and the denominator, okay? So I can really say that I have x squared minus 36 over the square root of x squared times x over 6. Well, the square root of x squared is x, and then I have I do have a x here in the numerator that divides out to 1. Okay, so those go away. So I can say that the tangent of the arc secant of x over 6 is equal to the square root of x squared minus 36 over 6. And that would be my final answer. Okay, so all of these are just kind of puzzle solving and trying to use sine, cosine, and tangent as much as possible because they're all inverses of each other. They're all reciprocals of each other. And so it's just trying to find the pieces to put in the right places. Like I said, we'll get into the differentiation of this a little bit later. I want to keep a whole separate section of that. I have posted to the course page, though, a list of the derivatives of inverse trig functions. So if you have any questions, please feel free to email me, and have a great rest of your day.